All right, so we'll get started. Okay, so today we're going to be finishing up what we did last time. So that was dealing with tables, and we're going to go over basically just the rest of the exercise. We have two more things to go over. So we're going to finish kind of, if you remember, we imported like Angels data, kind of made a table for Angel players on their own. So we're going to do that, and then we're going to have another exercise where we have a really big plot, and we're going to hopefully finish that up today. So we're going to be going till 10:50 because your quiz this time, I'm giving you even more time. It seems like quiz by quiz. It's going to be 25 minutes long. Now, don't freak out or anything about that. I took the quiz. It's only 3 questions, by the way. I took the quiz and it took me 15 minutes, but I was also watching a YouTube video too, so it's kind of distracted. So I want to give you plenty of time to do it. So it's going to be 25 minutes. So your quiz is going to start at 10:50. And also for this quiz, we're gonna do it a little different than before. So we'll talk about that now. I'm gonna have you submit your answers as a MATLAB file, so as a script file. So here we're at the quiz. So I don't want to scroll down too much because then you'll see the question. But this is going to be the quiz. You'll see the timer, of course, for you. It's going to show 25 minutes once you get into it. So make sure you read these instructions, but I'll go over it now too. Don't worry about specifying the line width for the plot. So I've been doing that a lot during our lectures where I make the line width 2. You don't have to do that for the quiz. I spelled plots wrong, whatever. So yeah, don't worry about that. And then again, we're going to submit, or you're going to submit a script file. So you're not going to type anything on Canvas at all this time. It'll be easier for me to grade your quiz where I can just download your file, I can run your script, and if it works, then you did everything correct. So you can just make a script file yourself, or you can download this template. So if I click on that, it's going to look, kind of weird here because Canvas can't really look at it well, but it can't render it correctly. So this is all it is, though. It's just a few lines of code. These are just comments up here. I'll actually show you what it looks like, but just some comments, and then we're clearing the memory, and then we have problem 1, problem 2, problem 3, just 3 sections right there. Okay, so again, you don't have to download this template, but you can if you want. Just be sure once you're done with the quiz, you submit your script file. So at the bottom of the quiz, there's gonna be a little option where you can upload a file. So make sure you upload your script file there. And then, so you'll see I have the questions kind of like the homework in a way. Let me open up the homework. So for the homework, I had them like this, right? Where I had the question here, and then I had the graph down here. So, and in this case, I had you plot this function for this x domain, and then I also had you do a least squared fit, and then you'd plot both of those. So I am going to give you the question up here on the quiz, and then I'll also show you what the plot is going to look like, or what it should look like. And for everything on the plot, you have to match it. So I'm going to have, specific line colors. I want you to match that. Specific data markers, so like a circle or a square or a dot, kind of like we've gone over. And you'll have to match that as well. And then you'll have to match what I have for the legend. So all of that's given in the instructions here as well. All right, and then points breakdown. So we have 3 questions, kind of a weird point total, I know, but I broke each question down for my solutions for how many points I'm going to give you for each part. So first question, 12 points, second, 11, and third is 14. Okay, so do we have any questions on the quiz? Okay. if our script doesn't run right, no, it's not going to be all a zero. If your script doesn't run right, I'm not just going to say, yep, you get a zero. I'll actually go through it kind of like I've been doing for all of the quizzes so far. I'll go line by line and see. Um, I'll try to give you as much partial credit as I can, basically. Yeah, no, I'm not gonna just give you all or nothing. Okay, so let's go back to MATLAB. Okay, yeah, I got it. Okay, so this is where we left off last time. Yeah, okay. Okay, so what I'm gonna do now, we'll just have a bit of review. So make sure you open up this file that we had from last time, and we're gonna finish up some of our exercises here. Okay, so get that file open, and then we can look at our table here that we imported. So at the very top of our script, let me make sure I have my font the right size. Okay, yeah. Okay, so at the very top of our script, we imported our table called headers. So if you see on the left-hand side, we have batters underscore regular season. So that's the file that we imported, and we imported it as a table using this line right here, headers equals read table. So that made this table right here. So we have quite a lot of stuff here. And then after that, we sorted that table by a stat called weighted on base percentage or weighted on base average, or you can call that WOBA if you want. So we're basically updating our table. So that's why we have headers equals. So we're kind of overriding what we have up here. So headers equals sort rows. Then we have to specify the table that we want to sort. And then we specify kind of our sorting parameter. So in this case, it's going to be weighted on base average. And this last part is optional. So I think by default, they do it by ascending. So, or ascend. But for us, we wanted to sort it by descending values. So at the top of our table, we have higher numbers. So if I look at our table and I look for that variable name called WOBA, we see it's right here, column 10. And at the top of the table, we have higher values, and they go lower and lower as we go down. Okay. Okay, and then we can do array addressing for a table as well. So kind of like what we've done with arrays. So here, I'm specifying the first 5 player names. So if I go back to the table, we see player name right here in column 3. So if I wanted to make an array, basically, or a string array because they're names, I can do that. So I make a string array variable here, which is f5 players, so first 5 players, equals headers, that's our table. And then we're using dot notation like we did a lot last class. So headers dot, and then we specify the variable name for the column. So in this case, it was a player name. And then we specify the first 5 values, so from 1 to 5. So if I go to headers and I look at 1 to 5, we see Juan Soto, Kip Ryan Hayes, Freddie Freeman, Marcelo Osuna. You get it. Okay. And then if I click on F5 players, we look at that, then we see those player names that we just said. Okay, so I just want to kind of refresh your memory for this stuff. We'll also comment this out. So last time, this was the plot that we made. It was a stem plot for top 25 players by weighted on base average. That should say weighted. And so we have all of our names here. These, we modified the X-tick labels to put in all of their names. And that was, we did that, I think we did that, yeah, by basically doing array addressing. And then we have a grid here, and I think some of you, I think there was like one or two where this plot didn't work, and I tried looking up if this was like a known issue online for MATLAB, and I didn't really see anything. So, it seems pretty bad where I'm just like, well, I don't know, but I don't really know. It should work. This stem plot, it was introduced in 2006. Is my mic kind of crackling? So it was introduced in 2006, and so it should work. Hold on, I'm gonna unplug my mic and plug it back in. Okay. Okay, so that should work for you. If it doesn't, you can stick around after class again, and we can try to figure it out. But it should work. I think it works for the vast majority of you. Okay. All right, so that was the plot that we made last time, and now we want to, or after that, we made a table, like a brand new table for angel players. So what we did is we made a string array here for angel player names. So this is kind of long. And then in this line here on line 33, we found the indices for all of those players inside of our kind of our main table, the hitters table that we imported in the beginning. Okay, so to do that, what we did is we used two functions, find and isMember. So find, that function is going to give us the indices for whatever we're looking for. So in this case, we do find, and then we're kind of specifying for our argument here the string array that we defined right here on line 32. And then the function isMember, that's going to look at our table, which is hitters, and it's going to give us a logical kind of uh, answer if our string array here, angels underscore n, if these players are in the table for that's called hitters, it's going to return a 1 if it's true and a 0 if it's false. Okay, so then we got those indices, and then we made our table now where we kind of do array addressing once again. So we look at our table hitters, and then we specify all of the rows or the indices for the angel players, and then we want to take all of the columns for them. So we put in that colon right there. And then if I look at our new table here, we see that we have a 10 by 31 table, all built up of angel players. Okay, so I know it's kind of a lot. It seems like some of you were maybe, not totally confident in this stuff yet, which is totally fine. But hopefully once we do these next two exercises and maybe look back at the slides, you can get a better grasp. Okay, so now we're going to make this plot here. So we want to make a scatter plot. I was going to have you do this on your own, this part, but I think I'll actually just go over it myself with you because I want to hopefully finish by 10:50 so you can do your quiz. Okay, so this is the plot we're going to make. So what we have to do is we're going to make a plot here for these two stats, slugging percentage versus launch angle. I guess if you're not a baseball fan, this seems like totally, arbitrary or it doesn't matter, right? But this is what we're going to do. So two different kind of parameters here or metrics. So we're going to make a scatter plot where we have slugging percentage on the y-axis and launch angle on the x-axis. Then we have our title, and then we're going to modify the limits and the tick values as shown in this figure right here. Okay, so let's do that. Okay, so I know that slide, it looks kind of small, but I'm going to tape it all up. Okay, so we sorted we need to sort our table right now. And we're going to sort it by slugging percentage. So we want to sort our table where It starts from the highest slugging percentage all the way down to the worst slugging percentage. Okay, so what we'll do is angels underscore t, because that's our table, equals sort rows. And then we're going to have angels underscore t. That's the table that we want to sort. And we'll put a comma, SLG, and then comma, descend. So if we look at our table, our angels table, if we kind of scroll through here, we see column 9. That variable name here is SLG, or slugging percentage. Okay, at first I thought it was already sorted by that by default, but it's not. We see that right now we have 0.6, 0.49, and then 0.646. So it's right now it's not sorted by slugging percentage. So we can run the script now. Now if we look at that table again, now it is sorted by slugging percentage. So we have 646, 603, 497, etc. Now it's descending. Okay, so we have that sorted, and now we can already kind of make our plot here. I'm gonna put that up there. And we can add a comment if we want. Sort table by slugging percentage. Okay, so now we can make another comment here. Plot it. Okay, so we're going to make a scatter plot, like I said. So, we have a lot of different types of plots in MATLAB. We can have just a regular old line plot. We can have a bar chart. We can have a stem plot like we had last time. And this time we're going to use a scatter plot. So we're just going to basically plot the individual data markers. We could technically do this with a regular plot command as well, where we could just do plot x comma y. Let's say we had that, and then we could just do some data marker like that. But we're going to use the scatter command here. So scatter, and then we're going to do on our x-axis the launch angle. So we're going to do angels underscore t. That's our table. And then we're going to use our dot indexing. So dot launch angle. That's one of our column names here. So launch angle, that's column 16. So that's just the angle of the ball when it's off the bat, basically. So angels dot launch angle. And then on the y-axis, we're going to do angels dot SLG for the slugging percentage. We're going to specify red this time. If I didn't have this command, it would do it. It would plot it. Let's actually run it. What did I mess up here? Angels underscore t. Oh, angels underscore t. There we go. So if I plot it, by default, this is what it's going to look like. Remember, by default, MATLAB uses blue for its color. And also, it's going to be kind of a hollow circle. Looks pretty bad. So we're going to change it. So we're going to specify this to red because we want red. It's the angels, right? Got to have red. And then we're going to specify filled. And that's going to fill in the circles. So now if we run it, this is what we have here. So this is our plot. So we have slugging percentage right here and then launch angle here. So we have to adjust some stuff. So I want to adjust the y limit. So, this point up here is kind of too close to the outer bound, and same with this value down here. All right, so let's do that. I'm going to put the plot over here. All right, so first we're going to add our labels just to get them out of the way. So we have the X label. That's going to be launch angle, not launch angel, launch angle. Y label, that'll be SLG, so our slugging percentage. And then we'll make our title angel slugging percentage versus launch angle. Now, if I run it, then all of those are going to fill in. Cool. Now let's adjust our limits and our x ticks, all that kind of stuff. This is going to be part of your quiz today. Just, this part where we adjust our limits and our x ticks, stuff like that. So we covered this part in the plotting chapter, so that's why it's fair game for the quiz. Okay, so right now we have our x limit going from 0 to 25. So I'm going to kind of scrunch this a little bit, kind of move it in, and I'm going to put it from 0 to 24. Okay, so we can do that. We're going to type xlim, and then we're going to have a left parentheses. And then inside of here, we're basically defining not a vector, but our minimum and our maximum value. Well, I guess technically it is a vector, but our first argument here is going to be the minimum x value. So we want 0, which is what we have by default here. And then I'm going to put 24. And that'll be the max value. So if I run that, now it changed a little bit here. So we kind of scrunched this graph a little bit. I'm actually going to change this to 1 to 24. And there we go. See, it also changed just automatically. It changed our x ticks here. So I didn't do anything. MATLAB kind of did it by itself. So that can be, somewhat annoying. This is actually what we want on the end, this kind of interval here. But we'll still actually specify how we want to do it. Okay, so there is our x limit. That's kind of how we want it. Now let's specify the x ticks. So again, it's like we want it, but just for the sake of understanding, I'll type out the command that we would use if our x ticks, if they looked a bit different. So we're going to do our command here, x ticks, or the function. X ticks, and now in parentheses here, we have to specify the ticks that we want. So we're going to essentially specify a vector. So we're going to give our starting value, then we'll give our step size essentially, and then the end value. So we're going to do 0, or actually we're going to do 2. So we're going to do 2, and then we want an interval of 2, so I'll do 2 again. And then I'm going to put 24. If I run that, everything stayed the same. Let's change this to 0 just to show that it's going to change. It should change. Actually, it's not going to change here. Why? Because our x limit starts at 1. So even if I had x ticks from 0 to 24, technically this is occurring. So there's like this kind of invisible x tick over here that shows 0. But since I constrained our x limit from 1 to 24, this isn't going to show up, this tick over here, because it's not, actually being rendered for the graph. So let's, we can change this from 2 to 24, but this time with an interval of 1. Now if I do that, now we got a whole lot more tick marks here. But I want to do, from a starting value of 2 degrees, we'll go in intervals of 2 degrees and then go to 24 degrees at the end. This looks a bit cleaner. Okay, and now we're going to do our y limit, or our y-axis stuff. So let's first do y limit. And in this case, we're going to have our y minimum value be 0.15. And this will just help us, once we plot this, we can see, yeah, this is our y, the minimum y value is too high, basically. So right now it's at 0.2. I want this data point to kind of, I don't want it to be on this boundary here. So I'm going to specify the minimum y value, or y limit, to be 0.15. And then same with the top here. This is too close to that boundary. So let's make the top, or the max y value, 0.7. All right, if I run it, now it's looking a bit better. Again, looking at this, maybe I would actually change it, but I want to kind of get through it. So, yeah, I would maybe change this to maybe not 0.7, but we're going to keep it. So it's at 0.7. Now let's do our y ticks. because you see that we're missing our y tick value up here for 0.7. So we y ticks, and then we're going to start at 0.15. That's the first value that we have. And we're going to go in intervals of 0.05 because we want to go from like 0.15 to 0.2, 0.25. And our last value, that's going to be 0.7. If we run it, then we get that y tick value to show up. Okay, so we have our plot here, but it's not very useful to us right now because we don't know who's who, right? If I was looking at this and kind of seeing which angel players really suck, I would know, but it would be hard to go like, oh yeah, this is I don't know, Luis Renjifo. This is Joe Adele. Not all of them, thank you very much. Although Trout didn't do as well this season as usually. He still did good. Yeah, Trout was still good, but Rendon actually hit better than him this season. Anyways, so we're gonna see visually, yeah, who all of these players are here that really are not good at hitting. Yeah, I'm a big Angels fan. And then, yeah, so we're gonna see all this stuff. This is kind of, I already did this kind of exercise on my own before just because it was interesting. So I thought some of you might be, I want to make it an interesting exercise. You're sorry. Yeah, I know. Okay, so let's finish this off though. Hoping the Astros lose, of course. It's looking that way. Okay, so we want to change it where we have a graph that looks like this, where we actually add in our our tags here or the text labels that we have. Dodgers are going to take it? I don't know. It's not looking too good for them right now. Okay, so we're going to change it like this. So I think we already did this kind of exercise before. Actually, no, we didn't. I thought we did. Guess not. So we're going to have these kind of, in quotes here, an automated text label. Okay, so this will be these two lines right here. So the first thing I'm going to do is I'm going to type in dx equals 0.3. Obviously just meaning delta x, and I have 0.3. This will be so I can I can have some parameter here to adjust where the text label is positioned. For now, I'm going to actually comment this out just so you can start to see why we're going to use that later on. Okay, so now we're going to put in our text command. So text. And then we have to specify, if you see here, we have to specify our x data, our y data, and then our text that we actually want to specify. So we can do, we can do an individual kind of x data point and an individual y data point, and then just one text value. Or like we're going to do here, we're actually going to have, basically we're going to use our string array. Okay, so we're going to put in our x data. So this will be basically a vector. So we're going to do angels underscore t. That's our table dot launch angle. All right, so this is just what we plotted up here, right? That was the x data. And then I'm also going to put, actually, I guess I won't put that in quite yet. So let's put a comma, and now we have to specify the y data. So angels underscore t dot slg for slugging. And now we have to specify the text. Okay, so for this, if I scroll up, we have our string array here, what's called angels underscore n. So you see my slides, I called it a different name, but basically we just want to take our string array for the angel players. So I'm going to put angels underscore n. And now if I run this, then there we go. Now we have our names. But you see here, the text kind of overlaps the data points by default. So that's, not what we want to have. So we're going to use this line of code here where we have dx equals 0.3. Now what I could do is I can go manually where I can go down here and put in plus, plus 0.3. So this is for our x data here. So when I put plus 0.3, that's going to shift our text by a value of 0.3 relative to our x data right here. So now if I run this, then you see that they all shifted over. And I could also do this for our y data. So I can go here and I could do, let's do like minus, we'll do minus 0.05, something like that. That'll be too much. But you see, then that's going to shift all of that down. Now, if I was going to kind of iteratively change this, or maybe I added more data in this plot, and I had to change these values, it'd get kind of annoying to go on this specific line of code, line 50, and adjust them like this. So instead, I'll basically put placeholders here. So all I'm going to have though is for the x data, I'm going to put plus dx. So that's our variable, and that's going to reference line 49 here, where we have dx equals 0.3. So if I want to change this later on, all I have to do is go to this line and I can change it to whatever I want. Let's do 0.5. That's a little too far over, so all I have to do is go to line 49, and I can do 0.3, run our code, and then there it is. All right, so we see, so I actually remembered a little wrong, but Luis Rengifo, he's down here. Terrible launch angle, terrible slugging percentage. Pull hole is not too surprising, nowadays. Slugging percentage, really not good. Launch angle, not terrible launch angle, but not great either. A lot of double plays he's grounding into. Otani, terrible launch angle this season. So yeah. Anyways, this is what we have here. I actually did remember right. So yeah, this isn't sorted right now. I guess in a way this is kind of good that I ran into this issue. So I need to go back to this slide here. And I think maybe I sorted our rows wrong. No, I didn't. I'm gonna have to go back and look at this part because yeah, how the text labels were defined, they actually weren't correct. So this is something, if you're doing this kind of automated method, you're gonna have to go back and make sure that it is correct, Oh, I know why. I did this before. So this right here, for this last argument, I put angels underscore n. And what that's doing, it's accessing the string array here, but this is just something that we defined ourselves. So what I have to do is actually use array addressing. I have to use the updated values for how we sorted our table. So if I go to angels underscore t, and I go by slugging percentage, then we see right here. And that should be top 3, Jared Walsh, Mike Trout, Anthony Rendon. Jared Walsh just going ham in, I think, September. Okay, so we got to change that. So yeah, this was a mistake that I actually made before, and I was like, what's going on? But it's because I specified our string array here when really I should be specifying the column in our table here. So let's do that. Where did I? Here we are. So yeah, you'll see on the slides I do have it correct, where we're doing the array addressing. So we'll do angels underscore t, and now we're going to specify that column. So what's it called? Player name. Yeah, player underscore name. Go to, here we are, player underscore name. Player underscore name. And then now if I run this, now it's actually correct. And this is how I remembered it. So Renhefo, he's still down there, and this is correct this time. So we can double check that it's correct by opening up our table here. So we see Lumis Renhefo, he's on the bottom by slugging percentage. That matches up with our graph here. Joadel, he's second to last by slugging percentage. That matches up here. And we have Otani, that matches up. So they're all correct this time. All right, so David Fletcher, right? Not, look at this launch angle, right? It's not high at all. But his slugging percentage, it's not good either, but gets on base a lot. I love Fletcher. And then as expected, we got Trout up here. Still pretty good slugging percentage. Rendon, it's still pretty good. Walsh, hopefully not an anomaly. Yeah, Listella, man, I love Listella, but I also kind of like the A's too, so even though they're out of it, but I was kind of rooting for them, even though they're in our division. Okay, so now we have this correct graph. So just make sure when you're specifying your text labels here that you use array addressing. Okay, so yeah, we're not going to be able to finish what I wanted to do today, but that'll be all right. I'll either make a video or we'll go over it next time, but I want to assign your project on Monday. So, and all of this stuff is going to be, as I said last class, very relevant for the project. Okay, so what we're going to do now is we're going to do a least squared fit. Hint, hint, this is on your quiz. Well, something like this, having a least squared fit. So we covered this in our plotting chapter, but we're going to do it again right now because we might have something like this on the project. So what I want to do now is I want to do a curve fit here for our data. And just by doing that, we can see a general trend here, where as our launch angle increases, generally speaking, our slugging percentage is going to increase as well. So we can kind of see that trend here. Now we do have some little anomalies here, like Walsh. He doesn't have a huge launch angle, but his slugging percentage was pretty insane. He'd probably go back to the mean though. Okay, so we're gonna do that now. So let's go up. We're actually gonna go up here, and we're gonna add in our polyfit and our polyval commands. Okay. So what we're gonna do is I first need to specify our polyfit. So I need to evaluate all of these data points and kind of make a linear fit to it. So I'm just going to call this fit so I don't have to type out too much. So I'm going to type out fit equals polyfit. And then we need to specify our x data and then our y data. And then n, that's going to be the degree of our polyfit. So 1, that's going to be a linear slope here. So let's do that. So angels underscore t dot launch angle, that's our x data. And then our y data is going to be angels underscore t dot slg, our slugging percentage. And then we're going to put comma 1 because we want a linear slope. If I run this right now, let's take a look at fit. So fit, we have 0.0126 and 0.2595. So what this is, it's just y equals mx plus b. So x here, we got our slope, or m, I should have said. All right, so that's the slope we have. And then now what we have to do is we need to evaluate for our y values based on our polynomial here that we just made and our x data. So we're going to do val equals polyval. And now you see we need to first specify the polynomial, which in this case will be this polynomial that we just made, which is called fit. And then we have to specify the corresponding x data. So we're going to do fit. And then in my slides here, I did from 0 to 1, or 0 where the step says 1 to 28. But we're actually just going to type in fit, because that'll be the polynomial. Or sorry, I don't want to type in fit. I want to type in angels underscore t dot launch angle. That's our x data. And that's going from 0 to 26. So, okay, so we have this now, and now I want to plot this. So we have our scatter plot here. And now what I'm going to do is type in hold on, because I want to add another plot. And this time I'm going to use the plot command because I'm plotting a linear line here. So I'm going to do plot. Now we need to have our x data. So that's angels underscore t dot launch angle. And then we're going to specify the y data, which in this case will be val. So that's polyval. That's the command that we used. And that was to evaluate our polynomial, which was fit with our x data, so we can get our corresponding y values. So I'll put in val right there. And I'll make this a red dashed line. Hint, hint, a red dashed line. And then I'm going to, after I type in a plot, now I'm done plotting for this graph, so I'm going to put in hold off. Let's run that. Oh, that looks like disgusting here. Why does it look all weird? It is dashed. On Linux, there is some rendering issues before you save the file, so that's why it looks kind of weird. But this is our fitted line that we have for the graph. Maybe if I change the line width, it would look a bit better. If I was going to save this file now, it would look good, but again, the kind of preview rendering for MATLAB and Linux is pretty bad. Okay, so then there is our fit. So on my slides, again, I did from 0 to 28. That was just so I could kind of extrapolate this linear fit here to start at the beginning x limit and the maximum x limit over here. Okay, so any questions on that, on this entire exercise here? Well, we have a 1 in line 38. Oh yeah, okay. So polyfit, again, that's going to basically make a curve fit, right? So we're making essentially a polynomial there. So if I open up our graph here, I want to make a linear fit or a polynomial or a curve, however you want to think of it for this data. So what I have to do, I need to evaluate all of our x data and all of our y data. And then that last argument, we have to put a number. So for that, in this case, I want to put 1 because 1 is going to represent a first order degree polynomial, or that's going to be just a linear equation. And because we put a 1, that's why we have a linear equation here, which gives us that, that linear slope. Okay. All right. Any other questions?
Professor, I'm having the same problem as last time.
Okay. Yeah, okay.
But I'm following along.
Okay. Yeah, I mean, you're going to take your quiz today, but maybe put a message to me in the Discord and add your code as well, and then I'll try to debug it. But yeah, we got to figure that out.
Yeah, thank you.
Mm-hmm. All right, so I just want to briefly show you what we're going to do either in a video like I talked about, or I might do it next class. So first we're going to talk about a function called string compare, which is similar for basically what it's achieving as is member. So we'll talk about that. Then we'll talk about removing rows. I think we talked about that before, but we're going to have a bit of a review for that. And then we're going to, sorry, I feel like I need to sneeze, but I don't. Okay, then we're going to make this plot. So this is going to be for all of MLB this year for the regular season. We're going to be plotting weighted on-base average versus exit velocity. So we're going to do this plot, and then we're going to be able to use our in quotes, our automated text labeling, where we can kind of make these labels for some of these kind of interesting outliers here. So our really good players up here are players that hit the ball hard but don't really get on base all that often. our players that are just terrible down here. No offense. And then our players up here that get on base a decent amount of the time, but they don't hit the ball hard. You see, there's not too many of them. Okay, so we're going to be writing code for that though, that can more easily automate it for these outliers. All right, so that's the plan. So yeah, again, I don't know if I'm going to make a video or we might just do it next class. Not too sure yet, but I'll let you know. All right, so the quiz is starting in 3 minutes. So if everything should work, but who knows with Canvas, right? There's been some issues. So you have 25 minutes to work on the quiz. Again, you're going to submit a script file for the quiz. At the bottom of the page, you can submit it there. All right. So I'm going to stay in here, but you can feel free to leave if you want, or you can stay in the call and you can message me if you have any questions. All right. So good luck. I guess I'll be here with my mic on right up until we start the quiz if there's any questions. And remember, you can either download the template script or you can just make your own script. I don't really care. Just make sure if you make your own script that it's clear which problem is which. So write some comments.